An apothem of a regular polygon is the distance from the center to the side of the polygon. A regular n-gon has n apothems. All are congruent. In the regular pentagon shown, each blue segment is an apothem. Note, the distance from a point to a line is defined to be the shortest distance. It's the length perpendicular to the side. So here we have the apothem. You can see that this triangle is created by the apothem and the radius of the circle. An apothem of a regular polygon is the distance from the center to a side of the polygon. A regular hexagon has 6 sides and 6 apothems. The length of the apothem is given by a, lowercase a, and the radius is given by lowercase r. What is the measure of angle beta here? In terms of a and r, what is the sine of beta? Well, the measure of angle beta equals 60 degrees, and the sine of beta equals a over r, because that's opposite over hypotenuse. In this case, it is 60 degrees. Since we're using the central angle here, the central angle of a hexagon is 60 degrees, because that's 360 divided by 6, and then the interior angle here is going to be the supplement of 60 degrees, which is 120 degrees, and this angle beta here is half of an interior angle, which is 120 divided by 2, which is 60 degrees. The area of a regular polygon can be determined by the length of a side, the length of the apothem, or the length of the radius. The length of the apothem is given by lowercase a, the radius by lowercase r, and the side by lowercase s. What are a and r in terms of s? Well, we have a 30, 60, 90 triangle here. Therefore, a equals s times the square root of 3 over 2. R equals 2s. The length of the apothem is given by a, lowercase a, the radius by r, and the side by s. What is the area of the hexagon in terms of the side length s alone? Not a, not r. Note, in a regular hexagon, r equals s. What is the area of the hexagon in terms of the side length s alone? There are 6 isosceles triangles that fill the hexagon. Each has a side length of s and a height a, which is s times the square root of 3 over 2. Therefore, the area of the hexagon equals 6 times the area of each of these triangles. And if you plug in the information, you get the area of the hexagon equals 3 times s squared times the square root of 3 over 2. The area of a regular polygon can be determined by the perimeter and the length of the apothem. Each of the 6 triangles has sides s and height a, which is s times the square root of 3 over 2. The perimeter p equals 6s. What is the area in terms of the perimeter p and the apothem a? Alright, so if you plug in 6 times the area of each triangle, and we have the area of the triangle here, 1/2 base times height, and height is s times the square root of 3 over 2. We can group these, s times 1/2 s. Remember, 6s is the perimeter, so we can replace 6 times 1/2 s with 1/2 times 6s. 6s can be substituted with p. Therefore, the area of the hexagon equals 1/2 the perimeter times a, the height. Alright, so the area of a polygon is 1/2 perimeter times a, this apothem here. Use the figure of the regular octagon to answer the true or false questions. Area of the octagon equals 1/2 p, which is 8s, times a, so this is true. The area of this triangle here equals 1/2 base times height, and here we have a base of s and a height of a, so that is also true. The measure of angle beta here equals 72.5 degrees. That is false. So it's actually 67.5 degrees. The way we figured that out is that an octagon has a central angle here of 45 degrees, because that's 360 divided by 8. So that would make this angle here, or the internal angle here, equal to the supplement of this. So 180 minus 45 gives us 135 degrees. Then we divide that by 2 to get angle beta here, which is 67.5 degrees. So this one's false. And then the a here, the apothem, equals r times the sine of 67.5. Alright, so what is the sine of this angle here, sine is opposite over hypotenuse, so a over r. So if we replace that with a over r, these r's would cancel and we would be left with a equals a, which is true. So those are our answers. Use the figure to answer the true or false questions. Alright, so we have a pentagon here. True or false, the area of the pentagon equals 20 times a. Well, the area would be 1/2 times the perimeter, which is 40, times a. So 1/2 of 40 is 20. This is true. Sine 54 degrees is a over r, not r over a. So this is false. Tangent 54 degrees would be opposite over adjacent, a over 4. That is true. Therefore, a equals 4 times tangent 54. So here we see tan 54 equals a over 4, so multiply both sides by 4, and you do get a equals 4 times tangent 54. So that is true as well. The perimeter of the pentagon is 40. P equals 5 sides, and each side is 8, so 5 times 8 is 40. The apothem of the pentagon equals 4 times tangent 54. The area of the pentagon equals 1/2 p times a. So we've determined that p was 40, and a is 4 tan 54. Therefore, the area is about 110.11 units squared.